one here. So as we've seen already over the last few days, it might be easier to just go on and graph it and see how many solutions we get from graphing. Six x to the fourth minus 11x cubed minus 16x squared plus 2x plus 4. So we'll type it into the graphing calculator, and once we get it typed in, we're going to hit graph. Is everybody able to get something that looks like this here? Now we notice that all the zeros are between -1 and 3. And if we look at our zeros on the table, well, we don't have it. So that means we don't have any integer solutions. So we definitely will need the rational zeros theorem to find our possible solutions. Now the number of solutions we're hoping to get, especially from graphing or the rational zeros theorem, is at least 2. Because if we can get 2, we can bring it down from a degree 4 to a degree 2. If we find more than that, if we find 3, it's a linear equation. Just x, we add or subtract and divide. And if we can find 4, that's even better. Because if we find 4, that means we found them all and we are done. But for this one here, we're going to have to use the rational zeros theorem. Our factors of p over the factors of q. Factors of p. P is the constant term. Factors of the constant term, the term without a variable. Well, our first set of factors, for in this case 4, would be 1 and 4. The others are 2 and 2, but we're not going to list 2 twice, because as we said yesterday with the rational zeros, any that are repeated, we don't write them twice. We just write them once. So having a second 2 is not going to help or give us anything we don't already have. Factors of q is factors of the leading coefficient. In this case, would be factors of 6. So we'd have 1 and 6 or 2 and 3. So the factors of q are 1, 2, 3, and 6. Factors of p are 1, 2, and 4. Questions on how we found these? P is the factors of the constant term. Q is the factors of the leading coefficient. P is the factors of the term without x. Q is the factors of the number in front of the variable with the biggest exponent. And we always do include the plus and minus. So the first one, we're going to start with q being 1. So we're going to divide each of the values of p by 1. So we do 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. We do need the plus and minus because it could be positive or -1, positive or -2, positive 4 or -4. So we have these here. So since we've gone through all the values of p, we change the q value from 1 to 2. So now we're going to do 1 over 2. 1 divided by 2. Doesn't reduce, so it's plus or minus 1/2. Our next one would be 2 divided by 2, which is 1. So we already have it. 4 divided by 2 is 2. Already listed, so we're done with that one there. Then we move on to 3. 1 divided by 3, plus or minus 1 over 3. Then we move to the next one, 2 over 3, plus or minus 2/3, 2 over 3. And lastly, 4 divided by 3 would be plus or minus 4 over 3. Then we move on to the last one, our 6. So we'll do plus or minus 1 over 6. Then we can do 2 over 6. Well, 2 over 6 is 1/3. 2/6. Is 1/3. 4/6 is 2/3. We already have both of those. So these are all of our possible rational zeros. Now the nice ones out of these are our positive -1, positive -2, and positive -4. But if we look at the table for this function here, 4, -2, -1, 1, 2, and 4, none of those give us a y value of 0, meaning none of those work. We can already eliminate those out. Now we're going to look back at the graph because we're going to use the graph and these possible rational zeros to try to find our solutions. Now the places where it crosses the x-axis is either between -1 and 0, 0 and 1, or 2 and 3, because those are the three spots we have. Yes? Because we have over here for between 0 and -1, over here at 0 and 1, and then over here in 2 and 3. And if we look at all these here, let me get a highlighter. Well, positive 1/2, -1/2, positive 1/3, -1/3, positive 2/3, -2/3, and positive 1/6 and -1/6. All of those are between 0 and 1 or 0 and -1. 4/3 is not. 4/3 is between 1 and 2, or -1 and -2, yes? Are there any values between those two spots? Let's look. Because -1 and -2 is over here. No. 1 and 2 is over here. Nope. So it works out that this one here doesn't line up with any of our solutions. And again, we're really just looking where on the x-axis do these lie. Now, as we saw yesterday, we could type this in, second trace. Second trace, and the first one is value. And the one we just eliminated was 4/3. Well, if I evaluate it at 4/3, we do not get a y value of 0. Second trace value, -4/3. Also does not give us a y value of 0, so those don't work. So we're left with these 8. Let's try one. Which one do we want to try next? 1/2. So in the graphing calculator, we can just say second trace value. 1 divided by 2 is 0. So we know one of the solutions is 1/2. We can try -1/2. We can go on and try it and see. Second trace value, -1/2 is 0.75. So it's close, but not quite there. I mean, if we want to, so we've tried positive 1/2, it worked, -1/2 didn't. The next one we could try is 1/3. 1/3 doesn't work. Wait a minute. The rest of the positive ones are between 0 and 1, yes? Did we find the solution of where it crossed the x-axis between 0 and 1? Well, it was what? 1/2, yes? So at this point here, actually in that box, hopefully that'll show up on the video, is 1/2. Could I have another spot at that location? Well, no, because we have 3 other places it crosses. So we found that value. So could any other value of x between 0 and 1 work? No, not for these here. So that means our positive 1/3, positive 2/3, and positive 1/6 are now gone. So we have 3 left. -1/3, -2/3, -1/6. value, negative 2/3, is 0. So I actually found the other one. And we could try the rest of them, but incidentally, those are the only two that work for this here. The rest of them are irrational. Questions on this so far? Now at this point here, we can do synthetic division. Again, you don't have to do this in your head. You can do this in a calculator pretty easily, because we can do 1/2 times 6, which is 3. Then we could subtract 11 from it and get negative 8. What I mean by this is we can do 6 times 1/2, 3. We add negative 8, negative 11 to it, thank you. Gives us negative 8 times 1/2. Then we can add negative 16 to it and get negative 12. Times that by? Yes, thank you. Because that's going to change things. Negative 20, yes. Times it by 1/2 gives us negative 10. 2 plus negative 10 is, and 1/2 times negative 8 is, which does give us 0. Yeah, if I'd have left it as the other way, we would have got a number other than 0. And we would have known that wasn't right because the graphing calculator already told us 1/2 was a solution, so the remainder has to be 0. Now, if we had 4 solutions, no, because there's going to be 4 answers for this, and we would need them all. But here we only have 2, so we're missing 2 answers. Because we could try negative 1/3, negative 1/6, but neither one of them work, unfortunately. Because what's happened so far is the degree right now is a degree 4 when we started. When we do this once, I'm going to put these variables back in just so we can see them. This would be the remainder. 8 is our term without x, 20 is our term with x, negative 8 is our term with x squared, and 6 is our term with x cubed. At this point, we really don't have a way to find or solve this here as it is. So we need to reduce that degree. Now we did find another value of x, which is negative 2/3. And if we do the synthetic division again, it's going to decrease the degree by 1, leaving us with a degree 2, which is a quadratic. And we have several different ways to solve quadratics. We don't have a whole lot of ways to solve cubics and quartics. So we do this method to really get it down to a degree 2. Once we have it there, we can use quadratic formula, completing the square or square root method. We have ways to solve those. Does that make sense? So this here is just trying to get us there. Now, if we had had all 4 answers, we're done. We have them all. We can move on.
So if we can put those, if we can put one of these in the calculator, count all 4.
Yep.
With x equals whatever.
Yes. And so it is nicer if we do have them all. Now here, we're going to do our multiplication. Negative 2/3 times 3, negative 4. Negative 8 plus negative 4 is negative 12. Negative 2/3 times negative 12 is going to be positive, because 4, 8. Negative 20 plus 8 is negative 12. Negative 2/3 times negative 12 is 8. Negative 8 plus 8 is 0. Questions on how we got to this here?
Yeah.
Which part?
To be honest. The part where we looked at the plus or minus at 1/2 plus or minus 1. So
P over Q.
like all of this up top.
P
Right, all of that.
over Q. What are the P values? 1, 2, 4. Divide it by
1 divided by 1.
I know that part, but like right after that.
1 over 2 is 2 over 2. What's 2 divided by 2?
0. Wait, 2 divided by
2. Is it already listed here? We don't list it again. Next one is 4 over 2. What's 4 over 2? 4 divided by 2. Is it already listed? We don't list it again. 3. 1 over 3. 2 divided by 3 is 4 divided by 3. That's it. Then we do 1 over 6 is 2 over 6. They both have a common factor of 2, which is 2 over 6. 2 divided by 6.
2 divided by 6. Wait.
Which one's bigger, the numerator or denominator, top or bottom? So both have 2. 2 becomes 1. 6 becomes 2 over 6. Mm-hmm.
It's pretty much, so when you do 2 over 6, you're going to try to...
I mean, different areas, but yeah, I mean, you can do it to solve for area.
So when you have a fraction, any fraction that you get, you're going to want to try to reduce it by as much as possible.
Yeah.
What if they just divide those by 2 or something? 2 divided by 2 is 2 divided by 6 is 6.
Okay.
And that's
Yep.
what you can reduce it without going like 5 or whatever.
And the last one, 4 over 6 is, yeah. Now, all of these here are the rational zeros. These are the possible rational fractional answers we could have for this polynomial function. We use the graph to determine which ones we could have. Which one of these values will make the y value be 0? Well, in the graph, being calculator over here, when we looked at the table, -4, -2, and -1 did not give us 0. 1, 2, and 4 also did not give us 0. So they're out. Then we started plugging in the calculator, letting it evaluate the others for us. So when we plugged in 1/2 into this here, it gave us a remainder of 0. So it works. We kept trying others. We tried -2/3. It also gave us. So it works.
If we didn't know, like the or important figures or whatever, we should just put that as the whatever second trace instead.
Yeah.
And we can see if that would do it.
Yeah. So we do second trace, and we can plug it in here because it lets us calculate any value.
So put all those in at first to see if we have all 4.
Yeah. 3/4. Doesn't work. And we could keep trying until we get at least 2, because here we need at least 2 to get the degree from a degree 4 down to a degree 2. Since we found 2, we have this here. Now, when we put the variables back in, 0 is our remainder, -12 is our term without x, -12 is our term with x, and 6 is our term with x squared. Because we're trying to reduce the degree down from a degree 4 to a degree 2. Because here, we can solve this. Because for any quadratic, the quadratic formula
So we can, that was 4, 3, that. I was a little confused on this part because I thought we were going to go 1 4, but I didn't know.
well, the most that we can do, because if we had a third, one that work, we would go a step further. Because we have 3 solutions, we can do this 3 times.
So we're just trying to get it down to having an A and B and C.
It's quadratic. This here is where we want to at least get to. Because if we can get to this here, quadratic formula, square root method, where we don't have a middle term, get x squared by itself, we can do one of those. But we need to at least get down to a degree 2. Because if we got down to a first degree, if we had one more, we'd have something like this here. Negative 12x minus 12 equals 0. Add 12, divide by negative 12, we have our answer. Because if we can have, for this case, 3, that would be better than having 2. But the best scenario is if we have 4. Because if we have 4, we have them all, we're done. But here, we only had 2, and that's fine. We get down to this here. Questions on this here? Is there a number that goes into 6x squared, 12x, and 12? There's 2 and 6, yes? If there's a number at this point, get rid of it. It's doing the quadratic formula with it being 6x squared, negative 12x, and negative 12. Makes the numbers a little bit clunkier to work with. Now we're going to plug it in to the quadratic formula. Now our a value is the number in front of x squared, which is b is in front of x, and c is our term without a variable, negative 2. So we plug this in, negative b. So negative, negative 2. Inside our radical, b squared would be negative 2 squared, minus 4 times a, so 4 times 1, times c, which is negative 2, all over 2a, or 2 times 1. So our negative, negative 2 is 2. 2 times 1 is 2. Inside the radical, our negative 2 squared minus 4 times 1 times negative 2. So negative 2, well, be nice and actually type 2 squared minus 4 times 1 times negative 2 is,
Oh, what did I do wrong?
you might have not put the parentheses around.
Oh, do I have to put the...
Yes, because it's going to, because negative 2 squared should be 4 minus negative 8. And I think you put the, didn't put that and put the radical.
Yeah, I did.
Now our square root of 12 is going to reduce to 2 square roots of 3. We can do that in the calculator, second square root 12. And the 30xs, the graphing calculator will give us a decimal. We'll use the 30xs, the yellow calculator, to get us this here.
What does that mean?
So it's 2 times the square root of 3.
So it's just do that.
Well, we can simplify it a little bit because these two 2's are both divisible by the denominator 2, yes? 2 divided by 2 is 1, plus or minus. Our 2 squared of 3 divided by 2. Well, the 2 divided by 2 is 1 times square root of 3.
So we don't put that one for that three.
We don't have to, no. So these here are the other 2 solutions. So our 4 solutions are 1/2, negative 2/3, and 1 plus or minus the square root of 3.
It's getting better.
Yeah.
I can understand it, but it's just a lot to keep up with.
Now in the graphing calculator, we can go second trace value 1 plus second square root 3. And it gives us this here. Now the 7.8 e to the negative 12, for all case and purposes, this here is just saying that we have 7.8 times 10 to the negative 12. And that is a decimal, 3, 4, 5, 6, 10, 11, 12, is this here, which is essentially 0. So if you do see, type these in, especially with the radicals, a number e to the negative 11, e to the negative, e negative 12.
So our other two solutions is that x
The square root of 3.
plus square root of 3.
1 minus square root of 3. Yes. Here, we did get a nicer value of 0. So it does work. And these here are solutions. Questions on this here? Let's look at this one here. X cubed minus 5x squared. Bless you. Yes. Yes. Minus. X to the third minus 5x squared minus 2x plus 4. Now, if we graph this one here and look at the table, we have a value of -1. But the other two do not cross at nice points. But we do have at least one value to start with. And the degree of this is 3. So if we want to get it down to a quadratic, we only need 1. So for this here, we don't even need to use the rational zeros because we have enough solutions to get it to a quadratic. -1 times 1 is? -1. -1 plus -5 is -6. -1 times -6 is 6. -2 plus -6 is 4. Maybe -4 giving us 20. I think let's x cubed. What's the last one supposed to be? 24. Almost. -2, 3, 4. How many do we have actually? How many do we need? How many do we have? So we are done. Questions on this here? Because we need 3. We have 3. We're done. Here, we only need 3. Here the degree is. Yes. All right, guys. Here we go. All right, guys. Last theorem we're covering with this section was 4-5. All right, guys. Irrational conjugate theorem. The main part of this is that if a plus b, a plus the square root of b is a solution, then a minus b is also. So if we have a plus the square root of a number as a solution, its conjugate, a minus the square root of that value, is also a solution. If we have one, we have to have the other. And that's all the irrational conjugate theorem is. So if 2 plus the square root of 2 is a solution, then
I always get confused on what the arbiter looks like.
yeah, all it is, it should say irrational conjugate theorem.
Oh, it's
Yep,
Oh, right here?
yep,
yeah, right here.
yep. So if a plus the square root of b is a solution, a minus the square root of b is. So if we're told that 2 plus the square root of 2 is a solution, 2 minus the square root of 2 is the solution also. If we have a square root, we have to have its conjugate, its opposite sign. So if the square root of 3 is a solution, negative square root of 3 is a solution also. Yep. Or if we said I squared root of 3, we'd also have negative I square root of 3. If we have one, we have to have the other. Now the last thing we're doing with this here is actually writing a polynomial. So we're given the solution, or so 3 I squared root of 3 and negative I squared root of 3. If we have one, we have to have the other. Now, what we're doing to finish this up is finding the polynomial function given the zeros.
Hamilton, come to the office. William Hamilton, come to the office.
Jimmy.
So here, we're trying to find the polynomial function that has these zeros, that has these solutions. So one of them is that x is 3, and the other is that x is equal to 2 plus the square root of 5. And because of our conjugate, irrational conjugate theorem, we also have that 2 minus the square root of 5 as a solution. So again, we're trying to find the polynomial function these go to. So we're working backwards from what we've been doing. Because on all the previous problems, we were given the polynomial and found the solutions. Now we're given the solutions, and we want to find the polynomial equation. Now for this here, they told us the zeros are these, so we set them equal to x. Now the first thing we need to do is get all of these equal to 0. So for the first one, we're going to subtract 3 from both sides, telling us x minus 3 is 0. And that's it. We have it equal to 0, so we're done for this step for this one here. Now we need to do the same thing for the other two. So for the first one here, we're going to subtract 2, telling us x minus 2 is equal to the square root of 5. Then we're also going to need to subtract square root of 5, telling us x minus 2 minus the square root of 5 is 0. Yes, we're moving everything over to x. And we'll do the same thing with the last one here. Subtract 2 first. And this time we're going to add the square root of 5 because this time the square root of 5 is negative. Questions on how we got these three statements equal to 0?
Why are you writing so big?
I don't know why. No, look how much room I have left. Like, this much room left.
Now we're going to multiply all three together. And once we finish multiplying all three together, we are finished with this one here.
Oh, that's it. Yes, sir.
Now, whenever we multiply these together, always multiply the conjugates together. So here, our x minus 2 minus the square root of 5, and our x minus 2 plus the square root of 5. Multiply these two first. So we're going to do x times x is x squared. X times negative 2 is negative 2x. X times square root of 5 is plus x square root of 5. Then we'll do the same thing with negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. Negative 2 times square root of 5 is negative 2 square root of 5. And lastly, our negative square root of 5, bless you. Negative square root of 5 times x, bless you, is negative x square root of 5. Negative 2, or negative square root of 5 times negative 2 is plus 2 square root of 5. And lastly, negative square root of 5 times square root of 5 is going to be negative 5 plus 2 square root of 5. And lastly, our square root of 5 times the square root of 5 is the square root of 5 squared, which is just 5. Because our square root and square would cancel. Questions on how we got to this here?
How do I start understanding stuff?
He does it over and over like this.
Why is this human brain
I don't know.
comprehend stuff
I
like
can't even
Now-
figure out what 2 divided by 4 is.
Back in here. Now, if we look through this here, all right, guys. If we look at this here, our x square root of 5 and negative x square root of 5 would be 0. Because x minus x is 0. They have the square root of 5. It's gone. Negative 2 square root of 5 plus 2 square root of 5. That would also be 0. Now what we have left, x squared, no like terms with it. Negative 2x minus 2x is negative 4x. And our 4 minus 5 is negative 1.
Sometimes when I look back at this, like the sum of factors, it just looks like all scribbles. Like I need to figure out a way to organize my stuff.
Colors.
Like I need to like get color.
Last thing we need to do is distribute this here. X times x squared is x cubed. X times negative 4x is negative 4x squared. X times negative 1 is negative x. We'll also distribute the negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is plus 12x. And negative 3 times negative 1 is plus 3. And when we combine like terms, x cubed does not have any like terms. Negative 4x squared minus 3x squared is negative 7x squared. Negative x plus 12 would be plus 11x. And lastly, we would have plus 3. Questions on this here? All right. So that is the end of that.
Oh, my man even think it's
They're all homework. Okay.
Homework is a worksheet.